Now come to the fourth one, which is the volume defect. This is known as three-dimensional. So first, which is the point defect, which is zero dimensional. Second one, which is known as line defect, it means one dimensional. Third one is uh, surface defect, which is two dimensional. And now we are moving to the fourth one, which is volume defect. It is three dimensional. Okay. So large scale description involves in multiple atoms. How? This is very simple. Here you can see the whole volume has moved from here. Okay. This is a, yeah, as you can see. So there are the three example. Now see what they are. First one is void. Void kind of things is like a vacancy where the all the region is empty. Okay, right, empty means there is no replacement of the atoms has been occurred. Okay, so the atom that was placed in that particular volume has moved away from their volume, their space, and now that space, that particular space is empty. Okay, so that is known as your void. So this one, the third one example, this is a void. As you can see here, this one is a void. Here the atoms that was present in this volume, they have escaped from here. Now it is a vacant or empty space. This is known as your void. Okay, now come to the description, which is very, yeah, empty space region in that is caused by the missing atoms as shown in the figure C. Okay, now come to the participant. Participate means cluster of the foreign atoms that form a separate phase. Okay, this is separate phase. As you can see here, this one. This is a separate phase. Okay, they all are in the different way. I mean, the molecules, atoms are present, but in a different phase. Phase means, I mean, if suppose this is a, kind of solid, so there must be kind of the gases. If gases has trapped in that particular volume, okay, so still they are the defect, but that defect would be counted as uh, participant means there is the different phase is present. Most of the time you can see here, I mean sometimes you are if you have a chance to make use a casting method. Okay, so in a casting method most of the times that you trap the air inside your solids, so that is also a kind of defect. But what the kind of the volume is occupied, the volume is occupied by the air. Air is a kind of gas, so gas has trapped inside your solid structures, and that why that will lose your strength and your that is the reason the casting method is a cheaper method, cheaper method, but the less or compromised kind of the property that you will get from your casting method. Because your defect, what the kind of the defect that mostly the casting method faces, that is the volume defect. And in volume defect you are basically participant defect, because in your casting method most of the time you get the air trapped inside your solids, and that will weaken your material. Okay, so this is your participant. If we talk about the inclusion, inclusion means non-metallic particles trapped in metals, often from impurities. Okay, so here you can see these are solid materials. Okay, this is the volume. I mean, is in this particular volume, some other solid materials are trapped. Okay, though I mean you can take the example of casting as well, in which the foreign elements or foreign particles have mixed together with your molten metals, and now they have combinedly solidified. Then you have the casting material that would have the defect, and that defect would be like the participant. Inclusion. Participant means of some other kind of phases is there. And inclusion, in inclusion you have the foreign materials or some other kind of materials that have come together during solidification, and they have solidified with your parent material, and now they have occupied the volume, uh, being solid. They are in the solid form. Okay, but still they are occupied the volume, and that is defect. That defect is known as your the inclusion defect, basically in a volume defect. So there are the three kinds of the defects in a uh, volume defect, right?